Hello, Assalamualaikum. Welcome back to my channel, and today we are going to discuss on voltaic cell or chemical cell. Dalam bahasa Melayu, sel kimia. Okay. Or so known as cell kimia. Okay, first thing first. This is the easiest I think subchapter in the redox reaction, chapter 1 from 5. Okay. So only few things that you need to know, but first thing first, I would like to explain on apa benda voltaic cell ni. What is voltaic cell? It is where it's a process lah. It's a process where electricity is generated from chemical energy. Okay. So you see, apa maksud dikatakan electricity is generated from chemical energy? Okay, so now as you already know, kalau we have a half cell, this thing already explained in standard electrode potential kan. Okay, so I'm just gonna make it this quick lah. Let's say we have a half cell here. Okay, so the properties of half cell is the electrode needs to be the same, of the same metal as the solution, as the electrolyte. So if you use magnesium electrode, the electrolyte must contain magnesium ion. Macam tu. Kalau it's zinc electrode, then it's zinc ion. Must be of the same kind of type of metal. Macam tu. Okay. So now what happened inside is there is transfer of electrons. So one party would donate electron and one party would receive electron. Okay. So sekarang, if you see now, electron is moving. Okay, dia bergerak from one point to another. It's moving. So when electron is moving, there electricity is generated. Okay. So again, I repeat, electricity is generated from the transfer of electron, from the movement of electron. Okay. So sekarang we can see that process. Oh my god. Sorry. Okay, so you can see that the energy conversion for voltaic cell is from chemical to electrical energy. Okay, so this is the energy conversion lah. So ini pun selalu juga masuk. Okay, so jangan jawab error lah. You should say chemical energy to electrical energy. Okay, remember, chemical energy ni is from what? Tadi saya cakap electron, the moving kan, electron moves, so electricity generated. Okay, so sekarang untuk SPM, you just have to focus on metal half cell only. Inilah metal half cell, the magnesium and magnesium ion. Contoh lah, okay, if zinc is zinc ion, macam tu. Okay, so next thing you need to know is there is two types of voltaic cell. Dua jenis sel kimia. Okay, boleh. So first I would like to call it, okay, we would call it simple cell. Simple cell. Okay, and second is what we call Daniell cell. I'm sure you've heard of this cell dalam buku teks, in textbook. Okay, so what's the difference between these two, simple and Daniell? Sangat senang. Simple would have one electrolyte, and Daniell would have two electrolytes. Easy. Okay, let's look at few examples. So sekarang I would like to explain on simple cell first. Okay, so sorry, not battery, but now we have our voltmeter. It is connected to our electrodes. Now our electrodes would be of the same, not the same material lah. Ini kan ada two electrodes, so two different electrodes. Okay, ni contoh je lah. Okay, let's say this is just a general idea of what is simple voltaic cell. Okay, so we have our electrolyte, we have our electrodes. So this is different lah, different electrodes, and we have our voltmeter. Okay, alright, now this is what we call simple voltaic cell. Okay, simple voltaic cell. Okay, so biasalah. This is sangat biasa. Okay, macam electrolysis juga. Okay, but electrolysis would have the same electrodes lah. Sekarang kalau voltaic cell, apa yang berbeza is instead of battery, we have voltmeter. Instead of electrode yang sama, now we have different electrodes. Okay, clear? Okay, now how about Daniell cell? Okay, draw here lah. So apa yang kita tahu, Daniell cell ni have two electrolytes. Two electrolytes meaning we need two beaker. Two different electrolytes, two beaker. And then we have our, each have own respective electrodes lah, okay? And of course our voltmeter and our electrolytes, okay? Alright, now if you see sekarang ni this setup tak complete tau. If we ingat balik schematic drawing in PT3, okay, let's say you have a bulb and stuff kan. This is something that I already explain jugalah sebenarnya benda ni. Okay, now if you see this schematic drawing, the bulb will not light up because the switch is not turn on kan. Dia tak complete lah. So electricity tak boleh nak move lah. So now what we have to do is we have to join this. Kita join kan. Sekarang barulah the bulb will light up. Sama juga dengan benda ni. Ini tak complete. Meaning that tak ada benda yang connect this thing to this thing. Okay. Kalau you tengok movement dia, macam lah, let's see, the red pen is electron. You can only move until that. Setuju tak? Okay, now what we need to have is a medium. Ya, kan connect these two. What we call salt bridge. Okay. Titian garam, salt bridge. Okay. Titian garam. Okay, titian garam. Alright. So sekarang barulah you can see that this circuit lah, this setup of cell kan, Daniell cell ni complete. Boleh. So now kalau kita tengok sekarang ada dua electrolyte, so I would say yang dua-dua ni sort of different kind lah, different electrolytes. Okay. And also yang ni electrode pun different juga lah. Okay. Second setup of Daniell cell is also we have again sama juga, we would have different electrolytes kan. So yang ni pula dia pakai satu beaker saja, tetapi dia akan ada, kejap, let me draw. Pardon my drawing Okay, now okay, instead of like this, kita akan ada ruang sedikit untuk our pasu berliang, or we call it porous spot. Okay. Okay, now inside the porous spot also have solution, different solution. Okay, so sekarang you can see that this is what we call porous spot or pasu berliang. Okay, now ini of a different electrolytes inside also. Ni pun dalam ni also different electrolytes. Okay, so now kita nak tengok function lah. So kita di bawah ni lah. Okay, function of salt bridge and porous spot. Okay, so kalau you tengok porous spot ni, kenapa ada kat situ? Sebab dia nak prevent lah from those two solution mixing lah. So you can say is to prevent the two solutions from mixing. Okay, and then they also allow ions to pass through. This is what I already explained lah tadi kan, about nak complete the circuit. You can also say that. Okay, to complete the circuit, to pass through, to complete the circuit, to complete the circuit. Sangat senang, very easy one. Okay, so that's it. So now kalau tadi kan ni contohnya Bila dah complete, so dia boleh ada produce a reading lah here. Okay, we produce a reading. Sebab apa? Sebab ada elektron bergerak. Ada electricity generated, ada reading on voltmeter. Sangat senang. Okay. So now I'm gonna break down our steps, okay? Step by step. Okay, this is all you need to know about voltaic cell. If you know this, senang nak buat, okay? Bagi je soalan apa, you boleh, insyaAllah boleh jawab, okay? So now I would, ni lah, nak break down into strategy, okay? Supaya senang kita nak tackle voltaic cell question. Alright, so first thing first, step lah, I break down to step, okay. Ni tak perlu hafal, tapi with practice you akan senang, okay? So first you need to obtain your half equation. Two half equations, half cells equation, and the E naught value from the SEP table. Okay, so standard electrode potential table ni perlu dapat dekat textbook. If I'm not mistaken, page 34 ke berapa, I don't remember, but it's from textbook, okay? From textbook, and then this thing is given lah, so no need to hafal. Dia given, this table is given. Okay, so I attach this one I copied from your textbook lah, memang exactly look like this, okay? So how to read this, nantilah I bagi tahu. Contohnya macam mana kita nak obtain two half cell equation ni. Let's say your cell involve, okay, sekejap. Let's say sekarang ni we have one magnesium electrode, one copper electrode, sebagai contoh, okay. So what you are going to do is, you ambil je lah from the table, you ambil yang ada copper. Cari lah one by one, nak cari mana-mana yang ada copper. Tu yang nampak ni, ada copper. So you salin balik, you tulis kat tepi. Tulis lah Cu 2 plus 2E Cu, and then don't forget to get the E naught value also. E naught value is macam ni lah. Kat atas ni senang. E naught value. Okay. E naught value for copper is positive 0.34. And then you're going to look for magnesium pula. Cari lah one by one. Ni magnesium tadi. Kan? So, tulis kat sini. Magnesium Mg2 plus 2E Mg. And then negative 2.38. Gitu. Okay, that's how you obtain the half cell equation, and then the E naught value also from the SEP table. Given the table is given. Okay, on to our next step is we need to know, second step, we need to know, identify which one is positive terminal and negative terminal. Identify which electrode is negative and positive terminal. Okay, so now lagi positive, meaning dia akan duduk dekat, okay, let's see, I ambil yang ni juga, dia punya soalan lah, contoh lah kan. Okay, so as you can see here, nampak tak ada sign kat depan ni, lain, positive and negative. So senang cerita dia, kalau nak tahu mana satu yang duduk dekat negative terminal is the one with the more negative E naught value. So sekarang mana lagi more negative? The magnesium, meaning magnesium is your negative terminal. Macam tu. So kalau negative ni positif lah. Sangat senang, okay. So the point is, ni tekan tepi lah. So sekarang cerita dia, more negative E naught value would be negative terminal, and then vice versa, more positive E naught value would sit at positive terminal. So kita tahu dah movement dia, sebab kalau voltaic cell, I'm sorry I forgot to mention kan, voltaic cell, kita punya electron move from negative terminal to positive terminal. Okay, this one hafal one, okay. Negative to positive. So sekarang ni you know already that electron move from magnesium electrode to copper electrode. So kalau disuruh lukis kan kat sini, lukislah macam tu. Okay, dia move from negative to positive, negative to positive. Okay, and then step 3. Clear? Step 3, now we need to decide direction. This one dah already cover lah tadi kan. Decide direction of electron. Decide direction and rewrite half equation. Yang ni kena arrow dia single direction arrow. Jangan ambil as it is. Don't take yang ni je lah as it is. Jangan ambil salin ni saja. Okay, jangan. Ini the one that you already ambil from table. Okay, tak apa. Kalau you tak clear lagi tak apa. This I just want to break down the strategy tau. Ni bukan soalan lagi. Okay, this is just example. Okay, decide direction and mind you direction would be from negative to positive. This is how electron move in voltaic cell. Okay, and then kalau kita nak cakap pasal negative to positive ni, we can see that yang negative terminal ni would donate kan. Ni negative terminal ni akan donate elektron. Sebab elektron bergerak from negative to positive, of course, yang duduk dekat negative terminal akan donate. While yang positive akan receive elektron. This one donate elektron, ni receive elektron. Okay. The fourth one would be to write your cell notation. Cell notation. Okay, cell notation ni ni nanti I explain. Okay, about cell notation ni very easy one. Okay, Teng. Okay, this is all you need to know. Ni macam kira macam barrier lah. This is like a barrier, and then tak payah tulis lah barrier. Okay, tak apa. Sekarang yang duduk dekat sini, ialah benda yang berlainan. Okay, so yang duduk on the left hand side is your negative terminal. And ni would be your positive terminal. Don't worry, maybe you get macam, apa benda ni? Tak faham. Nanti you akan faham. Okay? Nanti I bagi you soalan. Kita buat sama-sama. Okay? Our fifth step is to calculate your E cell. E naught cell. Okay? So E cell ni ada formula dia. Very senang. Very easy. Okay? E cell is basically is E yang duduk dekat positive terminal, you minus with E who sits at negative terminal. Senang sangat nak hafal. Yang besar tolak kecil. Bukan yang besar, tengok dia punya magnitude also. Tengok yang mana lagi positif, dia akan tolak yang lagi negatif. Macam tu. 6 just to describe observation. Okay, describe observation ni sama lah macam electrolysis juga. Okay, kena describe colour, kena describe kalau dia gas, colour of the gas. Kalau dia tak ada colour, then you have to describe. Contoh kalau dia oksigen dengan hidrogen kan, dia tak ada colour kan, so you have to cakap gelembung gas atau bubble. Gelembung gas ataupun bubble, gas bubbles is observed. Okay, nanti I break it down, I tulis in table. Okay, so remember observation is what you see. Itu saja yang kena ingat, what you see. Okay, let's tengok contoh. Okay, sekejap I nak tukar dia jadi paper. Alright, mari. Okay, so one example. Tak ada lah, satu saja. Okay, so let's say I have a voltaic cell, sel kimia yang mempunyai comprising of Al, aluminium and copper. Okay, in their respective electrolyte lah. Contohnya ni ada dia punya in their respective electrolytes. Okay, so I'm going to draw you the ni lah setup lah. Okay, so let's say we have tadi dia kata kita ada Al and kita ada copper, and they each have their own respective. Masing-masing ada mereka punya electrolyte masing-masing. And of course, we're going to need our salt bridge. Voltmeter and salt bridge. Okay, now. Okay. Sekarang ni, tak kisah, you letak je. Ni contoh aluminium, ni contoh copper. Ataupun dia ada way round pun tak apa. Position doesn't matter as long as you know which one is your negative and positive, you're good to go. Okay. Nanti you just going to draw lah mana elektron pergi. Okay. So, macam ni setup dia sangat senang. Okay. So, dah faham kan kenapa ada salt bridge and all? Aduh. Okay. And then, dalam electrolyte ni, of course, kena ada solution yang ada the same material. Ingat tak I pernah cakap tadi? I cakap tadi kan, dah explain dah tadi awal-awal. So sekarang dalam larutan ni Al, so the thing needs to have Al. Garam ni punya Al lah. So tak kisah aluminium nitrate ke, chloride ke, sulfate ke, sulfate ke, tak kisah. Okay, so we're just going to do aluminium nitrate. Okay, tak kisah as long as it's of the same material, of the same metal. Okay, ni pun sama. Ni hitam lah, tak kisah. Copper, sulfate. This is just gambar lah. This is just macam dia tak bagi tahu kan. So kita boleh cadangkan lah apa-apa. Okay, this is just analysis lah. Okay, so now kita ikutlah follow step by step. Okay, so step 1 tadi is untuk mendapatkan kita punya half cell equation. Okay, half cell equation from the table. So we have aluminium and copper, so we refer to this table. Okay, I padam dulu. So we cari aluminium and copper. I see aluminium here, and I see my copper here. Okay, and also kita akan mendapatkan dia punya E naught value. Okay, so sekarang you're going to salin balik. Salin balik lah. Okay, jangan risau, itu given. Okay, so you salin saja, salin as it is. Salin dulu with the double arrow, and then we have our E naught value is negative 1.66 volt, and then our copper is positive 0.34 volt. Okay, so now settle step 1. Step 2 is to identify mana satu negative terminal, mana satu positive terminal. Okay, so from what I see here, nampak tak dia punya sign ni? So it's clearly that siapa yang duduk kat negatif is yang lagi negatif, meaning aluminium will sit at negative terminal. Okay, settle. Third step is to write your half equation. Step 3, half equation. And then kita tengok direction of our electron. Okay, remember, elektron bergerak dari negatif to positif, betul? Elektron bergerak dari negatif to positif. Sekarang you are going to label dulu. Mana satu negatif? Tadi negatif kata aluminium. So now this is our negative, this is our positive. So sekarang kita punya elektron bergerak macam ni. So siapa yang akan menderma, siapa yang akan terima? Obviously aluminium akan menderma. Okay, so you can write lah macam you can do mental note lah macam okay, aluminium itu dekat tepi kan, aluminium donate, and then copper receive, macam tu. Okay, so now you're going to adjust your half equation. So sekarang siapa yang akan menderma? Of course the electron akan sit at the right hand side. Boleh tak? Logik tak? Okay, so sekarang we know that in donate akan electron sit right hand side. Macam tu. So you're going to switch this part to the right hand side. Aluminium. Sekejap. Ni I write what happened at negative terminal lah. At negative terminal, what happened here is aluminium akan duduk kat right hand side, left hand side, and then yang dah ada elektron tu akan duduk dekat right hand side sebab dia menderma, donate. Okay, faham tak? Faham tak how to write the half equation? Okay, boleh tak? Logik lah ni sebab ni before Ini after. After ni nampak tak, dia dah terpisah dengan elektron dia. So maksudnya dia dah donate, dia dah bagi dah. Macam tu. Boleh faham tak? Okay, please faham this one first. Okay. And then kalau yang receive tu, meaning before tu dia dah receive dah. So maksudnya dekat belah kiri ataupun left hand side dia akan ada elektron. So ini tak payah tukar lah. Okay, tak payah tukar lah. Tapi don't forget to change your arrow ni jadi single arrow. So Cu2 plus 2E menjadi Cu. This is in positive terminal. I forgot to write that. Positive terminal. Okay, boleh. Alright, now on to our next step, fourth step. Step 4. Sorry kalau banyak pergerakan, I'm so sorry. Step 4. Okay, now step 4 ni is our cell notation. Ni yang I nak explain sekarang. Okay, cell notation yang tadi yang kita faham. We have our barrier here, and then kita akan ada before after. Okay, so basically yang ni ialah tempat kita letak kita punya negative terminal punya metal. Ini positive terminal. Okay, so this is ni bukanlah answer lah. Ini macam your, ni tak payah include pun tak apa, but I just want to show you lah. Okay, so what happen here is you pergi tengok kat negative terminal. Negative terminal is yang mana satu, ni kan? Okay, so sekarang yang duduk dekat belah kiri, you tulis belah kiri AL, and then belah kanan you letak belah kanan. Tapi jangan letak elektron lah. This is just the aluminium lah, aluminium ion. Okay, not electron. Okay, so that's it. And then positive terminal, belah kiri we have Cu2 plus, belah kanan you have Cu. Okay, this is one mark. Okay, this is one mark. Nak lagi satu markah, you put your state. Okay, so aluminium ni dia ialah pepejal, so we write solid. And then aluminium tu ion meaning dia aqueous, so you write aqueous. And then this one is aqueous also, and then this one is solid. Satu, 2 marks. Senang tak? Sangat senang. Okay, before after. Kalau you perasan ini ni what happen before, ni before, ini after kan. Ini before, ini after. Very easy one. Okay, clear? Okay, how about step 5? Sikit lagi nak habis dah. Step 5 your E0 cell. E0 cell sangat senang. Formula is E yang mana? Kecil tolak besar ke besar tolak kecil? Of course, yang besar tolak kecil. Besar meaning yang positif lah. Positive terminal would minus the negative terminal 1. Okay. Now, E0 yang kat positive terminal. Siapa duduk kat positif tadi? Copper. So, positive 0.34 minus negative 1.66 minus, careful of the negative ni most students selalunya lupa nak letak negatif, so nanti dia jadi tolak lah. Okay, so sekarang positive 0.34 minus negative 1.66, you would get 2.0 volt. Okay, sangat senang. Last kali, step 6. Okay, so step 6 ni of course kita akan ada observation dekat dua-dua terminal. What happen? Okay, I like to see from the half equation tau. Okay, so you tengok balik your half equation. Let me clear this one. So apa yang nampak dekat ni, apa yang nampak dekat negative terminal and positive terminal ni, kita tengok negative terminal dulu lah. Aluminium change to aluminium ion. So from apa ni sebenarnya? Ni solid tau. Ni solid. And then dia jadi apa ni? Dia jadi ion, dia jadi solution. So tak ke dekat sini, kat aluminium ni ni lukisan ni lah. Dia from solid, dia jadi ion. Meaning dia corrode. Betul tak? Dia dissolve masuk dalam solution ni. Betul? So dia just sebenarnya dia mengurus tau sebenarnya. Dia kurus balik. Kurus tau. Dia macam it will end up like that sebenarnya. Setuju tak? So that is your observation. Remember what you see. So you can simply say your aluminium electrode dissolves, or just simply aluminium dissolves. Kan? That's what happened. This is what I have explained in pengaratan rusting juga. Bila metal tu donate electron, when metal dia donate electron, dia akan jadi apa? Donate, oh my god, electron donate electron, it will dissolve. Setuju tak? Okay, logic only kan. So itulah berlaku. Just simply say aluminium dissolves, settle. Okay. How about the positive terminal? Jom kita tengok half equation. Copper ion become copper. Macam mana ni? So from ion ataupun kita punya solution, dia akan jadi solid. So yang ni kena back to our pemahaman in garam. Apakah warna copper? Copper solid. It is brown. Okay, it's brown. Okay, it's brown in color. Sorry. Okay, it's brown. So you can say brown copper pun brown solid is form. Gitu. And then ada another observation you can see sebenarnya. Tadi kau nampak kan, ion dia jadi solid tau. Okay, you bayangkan dalam kita tengok ni, kita zoom kat sini. Dalam copper ion ni, copper solution ni, electrolyte ni, ada copper ion. Betul? Copper ion warna apa? Copper ion warna biru. Sekarang this copper ion, you bayangkan tak, from 4 dia jadi, contohlah, kan copper ion ni kan tadi kan dia dah receive electron and then dia jadi solid kan. You bayangkan yang ni dengan yang ni dah jadi solid, let's say kan. So sekarang tinggal apa? Tinggal 2 sahaja. Meaning tadi kan banyak, ada 4 kan ion copper, but now left with ada 2 sahaja. Only 2 left. Okay, so what you can say is warna biru tu akan, the blue color will become lighter. Betul tak? Setuju tak? Sebab apa? Kekurangan Cu2+. Because Cu2+ becoming Cu. Okay? So apa dia? Less Cu2+ in the solution. Contohlah ni macam just explanation yang barai-barai mana. Okay, so now if you understand, kita boleh tulis dalam jawapan kita. Brown solid is formed and also blue color solution, blue color of solution becomes lighter or paler, tak kisah. Okay, boleh faham ya? So that's it, our 6 steps untuk approach voltaic cell. Any voltaic cell you can selesaikan sekarang. Okay, so ni I bagi you soalan yang susah-susah lah. Bukan susah, tapi ada 2 electrolyte and stuff kan. This is kira macam complicated lah daripada simple cell kan. Okay, so boleh so that's it. Thank you for watching. Make sure to like and subscribe. Okay, bye-bye.